Thank you. It is such a privilege to be with you all here today. I'm here on behalf of a company that has taken part in every stage of the global electrification, these challenges of generation after generation to generate power. And if you look across the US landscape today, what you'll see is that there's Siemens gear in about a third of all the power supplies across the United States. You know, we've come to this space with this great deep knowledge in electrification, but we've augmented our capabilities now by turning ourselves into one of the top 10 software companies in the world. We've added to our portfolio automation and digitalization. And these are the capabilities we're very proud to bring to this partnership with universities, with national labs, with other industry partners, and with you, ARPA-E. And honestly, it's a privilege to be here on your 10th anniversary. Now, what I'd like to do is note another anniversary that we're going to be celebrating. Later on this month, we'll be commemorating 50 years since Neil Armstrong took those first important steps on the moon. And it's important to think about what went on behind the scenes. I was a math major, and so I was struck by the movie Hidden Figures. The idea of Katherine Johnson, the computer, who used ancient mathematics to help make this brand new technology effective and allow it to accomplish this once-in-a-lifetime true moonshot. You see, it's this combination of people and technology that we focus on, and this is how we think of ourselves at Siemens. We're bringing technologies that help innovators, the people who are pushing the boundaries of science and technology to expand what's humanly possible. An example of how we're doing this today is this work that we performed with NASA. That Mars rover Curiosity that you see depicted here simply could not have been built in the analog world. There's no way to replicate the environment of Mars on Earth. And so what NASA did is they took advantage of the technology we have in Siemens product lifecycle management in order to simulate and refine and design and then practice that fateful landing on Mars literally thousands of times so that we knew for sure it would be successful. It's this combination of hardware and software know-how that's making a whole new realm possible to us. Now think back over this last century of innovation and think about what people called the American century. In the year 2000, when the National Academy of Engineering came together to talk about what had been the most notable advances in technology, it wasn't the space program. It wasn't computers. It wasn't the automobile or the internet or even the telecommunications that were so dramatically changing the world around us. It was the power grid. The electric grid. Without the electric grid, none of the other things on the list would have been possible. I recently read the best-selling book, Sapiens, by Dr. Yuval Noah Harari, and he calls electricity our universal genie in a lamp. And so what we need to do as humanity today is to ask ourselves the question, what are we asking for from this ultimate power? Our CEO of Siemens globally, Joe Kaeser, recently spoke and referred to what he called the moonshot of this generation. What we need to be focused on is coming up with a way to provide clean, affordable, reliable power, especially to the 1 billion people around the globe who have no power at all, and the 1.5 billion whose power isn't reliable. We know that we have the technology, And Joe is encouraging all of us to come together as a community to drive this Moonshot project of our day. Now, as we think about this, we're thinking about what existing global trends are there that we need to harness in order to accomplish our objectives. It's interesting, I'll share with you that Siemens is a company that has built its business strategy around inexorable forces shaping our world today. These global megatrends. And as you look across this landscape, what you see are things that none of us can argue with. We know that lives are longer. The first person who will live to be 150 years old has already been born. We've got an ever-increasing global supply chain. But think about urbanization. 2007 was the first year that as many people lived in cities as in rural areas. And we estimate that by 2050, 3 out of every 4 people will be living in urban environments. And climate change, we're talking about all that all the time now. Just the storms that were affecting us over this last couple of days, you could hear people positing that it really is the effect of these changes we're experiencing that are leading to a new reality. But look at this item in the center. It's less of a trend than a golden opportunity, the digitalization of everything. We think a lot about the 4th industrial revolution and the ability to use data in order to transform everything in our built environment. Imagine bringing the power of computing that has changed everything about our consumer worlds, that has brought us tools into the palms of our hands. Imagine translating that into our fixed environment, into our cities, the built infrastructure, and even into our power and energy systems. That's the world that we're going to be creating together. As the CEO of Siemens USA, I asked a small team to pause and to take a look at, as we look long-term, out to 2050, what are the things that have to happen in the next 10 years? How will these global megatrends shape our work as we think about the future? And here's what we talked about. First, distributed energy. I mean, we can all see it happening right before our eyes. In fact, I would say we're powerless to stop it. It's becoming more decentralized. It's becoming more manageable. The tools are in our hands today to actually bring clean sources of power onto the grid. But in order to manage this, we're going to need to be able to bring the digital tools that will harness the two-way flow and that will help us to match supply and demand. I've been wondering whether we can find analogies to this anywhere in the world we've been dealing with over the last couple of years. And one idea is to take a look at computing. From mainframes to desktops to handheld devices, now back again to cloud computing. I think we can look to other analogies that have already taken place in markets around the globe and ask ourselves, what can we learn so that we can drive this transition ever faster? But a second trend that we know is coming and that we have to be ready for is e-mobility. Now, we're anticipating that we'll grow from today's 1 million electric vehicles on the road today to 18 million in the 2030 timeframe. That's not a lot when you think about the number of vehicles we have on the roads today, but think about the implications. The entire infrastructure needs to be rethought. We need to bring clean electric power into cities so that they can effectively harness the potential of these new connected, mobile, electrified assets. And it's not just automobiles. Siemens has been working hard on the electrification of propulsion for maritime applications. Whether we're subsea or surface, the concept, the reality of electric propulsion, for pure propulsion or for auxiliary power, they're both there and available to us today. These are opportunities that are right within our grasp. But how are we going to realize these? Let's pause and think about the absolutely essential factors as we make this move into the new digital world. And two key components I want to talk about are cybersecurity and the workforce. Now, think about this from a cybersecurity perspective. As we become more digital, it means we're sharing data. Data's flowing. Now, suddenly, we are vulnerable to cyber attack. Some people had said to me, thank goodness we have an analog grid. Well, not really, and not for long. We have the tools today to help us monitor and plan. We have tools that are going to enable us to be much more automated when it comes to the cybersecurity of our physical assets. And some would even say, ascribing to a myth, that augmented intelligence will take over our jobs. The fact is, nothing could be further from the truth. We need millions more cybersecurity experts around the world than we have today. And that's why we're taking a tremendous investment now into the workforce of the future. At Siemens, we're spending a lot of time working with apprenticeships, with university relationships, building programs that are helping our own employees as well as those of our customers and people who will ultimately work in this ecosystem to create the skills, advance their careers, and be available to help solve these absolutely essential challenges of the future. The first time Siemens connected a turbine to for remote connectivity and for remote maintenance was actually in 1977. That's what you're looking at here. And you know, the key thing here is that innovation sometimes takes patience. In 1977, it was still 10 years before the internet was available to us. The team spent the ensuing 10 years finding ways to connect assets remotely in hospitals and in factories. But it was not until about 2007 that we had the technology needed in order to begin to truly harness the promise of digital. All of those things came together about the same time that the iPhone came on the scene. The technologies that made that possible also made it possible for us to begin to connect these assets. Now we have the ability to remotely monitor, to remotely perform ongoing maintenance. We have the ability to think about how to optimize operations, and we have the ability to introduce new business models that were never possible before. All of that through patient persistence in bringing about the technology of the future. We don't do this alone. None of us do. In fact, that's the power of a meeting like this. Each of us are coming to the table with things we know, things we're dreaming about, and we're meeting colleagues who likewise are devoting their time, energy, and attention to solving very specific problems. But who knows what's possible when we begin to combine these technologies and work together. And that's why I'd like to close with a thought about the human impact at this point in the world's history. And I'll bring you back to the work Sapiens. I know there was a lot of controversy when it came out. The scientific community really wondered about some of the things that Dr. Harari was positing, but I appreciated the thought process, the work. One of the core concepts he introduced in one of the last chapters is this idea that we have, over these ages, been about transforming energy. It's energy and the ability to harness it that brought about the industrial revolutions that created the world that we have today. And there are those who ask, aren't we about to run out of energy? Aren't our energy resources finite? And the fact is, instead of asking what should we be doing when energy runs out, we need to ask another question entirely. That question is, what do we want? If we can focus intently on the outcomes we want to drive, believe me, with the brain power in this room, we can make any of it happen. You know, the wind turbines that Siemens Gamesa can make in a matter of weeks can power small cities. You all know as well as I do that there's enough solar power hitting the earth every 90 minutes to power all of our human activities for an entire year. That's not the question. The question is about what are we going to do to harness that power, find new sources of power, find ways to balance what we need for the energy demand of today and tomorrow, and the need to sustain our planet. The tools are here within our hands. And remember about that extending life's age? Well, I think that can also extend careers. And so after having been here for your 10th anniversary, I'm looking forward to being back for your 20th, because I can't wait to see what you managed to pull off by then. Thank you very much.